हेलो एवरीवन, वेलकम बैक टू अनदर वीडियो ऑफ कॉन्सेप्शिया। आज की इस वीडियो में मैं कुछ चीज़ें आपको बताना चाहूँगा। सबसे पहली चीज़ तो ये है कि इंशाल्लाह हम अपनी इस जो है सब्जेक्ट वाइज सीरीज़ को कंटिन्यू करने लगे हैं ड्यू टू सम रीजंस। और आज की इस वीडियो में हम बात करेंगे असेंबली लैंग्वेज की, कंप्यूटर ऑर्गेनाइजेशन एंड असेंबली लैंग्वेज। सो इसमें एक इम्पॉर्टेंट टॉपिक आता है हमारे पास के रजिस्टर्स क्या होते हैं, उनके ऑप कोड्स क्या होते हैं, इंस्ट्रक्शंस की कमांड्स क्या होती हैं, वैलिड इंस्ट्रक्शंस क्या हैं, इनवैलिड इंस्ट्रक्शंस क्या हैं, रजिस्टर्स की टाइप्स क्या हैं, और इसके बारे में हम पढ़ेंगे। और जो हम यूज़ करने जा रहे हैं वो आर्किटेक्चर, हम x86 आर्किटेक्चर यूज़ करेंगे। X stand for dual core and 86 is the architecture, like it stands for 64-bit 32-bit usage of Intel. Specifically we are talking about the Intel x86 processor. So today in this video we will be going to explore the core components of x86 architecture and learn about the general purpose and segment registers, understand their roles in data manipulation and memory management. So what are general purpose registers? There are basically three types of GPRs. First one is the arithmetic and data, and it is used for arithmetic operations and data storage. The second one is the memory addressing, and like it stores the memory addresses of the instructions. And the third one, you can say it is a combination of both. Like there are various sizes. It is available in 8-bit, 16-bit, 32-bit, and 64-bit versions, talking about the register size. So let's talk about the segment registers. So there are further three types of segment registers, mainly that are code segments. It holds the code segment, like where the code is located. And the second one is the data segment, and it actually stores the data, the real data. And the third one is the segment. So stack, talking about the stack, is like LIFO principle, last in first out. And in the memory, we prefer to store the instructions in the least tracks. So whenever like if our memory is compromised, the person who is trying to access can just you can say like he can access the least tracks and steal the instructions, or actual data is present in the highest tracks. So here is a move instruction example. Here move is an opcode, and if we talk about a 4-bit number like 1 2 3 4, so the first bit, the MSB, the most significant bit, one talking in this example is the opcode. So look at this command, instruction, sorry, move AX comma BX. So it basically moves 16-bit data from BX to AX. So what is BX and AX? We're going to talk about it later in the slides. Then second example is move BL comma CH. So the basic syntax for the instruction is that first we have to write opcode move, then we have to write destination comma, then we have to write source. So here source is CH. So what is CH? CH is the counter higher bit register, and BL is the lower bit base register. So it will just move 8-bit data from CH to BL. And move ESP comma EBP. Here EBP and ESP, we will talk about it in the next slide. It is just copying the value from EBP into the ESP. So next one, 8-bit and 16-bit registers. 8-bit registers are AH. AH stand for accumulator higher bit. Then AL, accumulator lower bit. BH, base higher bit register. BL, base lower bit register. C stand for counter higher bit. C stand for again counter lower bit. DH for display, data. And DL for and lower bit. So basically D is like for output, and the A is for the input, and B is a multi-purpose. It is also used for inputting data and also for the manipulation of data, and C is basically um, for the counter and like data processing. So 16-bit registers, here it is the extended version. X stand for extended, and it includes H and L both. And talking about SP, it is the stack pointer register. BP is the base pointer register, and SI and DI are the index register of stack and display. So let's talk about what are the invalid move instructions. Like you can replace the opcode here according to the scenario. Like here opcode can also be load for loading LDI, for storing STO, for sub SUB or subtraction SUB, for addition sum. So sum or add is preferred. And here is instruction is written move BL comma CX. So as we talked that CX is a 16-bit register. So we are going to move our source is CX 16-bit register and destination is BL, which is a 8-bit base register, lower bit. So we are going to transfer 16-bit data into 8-bit register, which is invalid because size mismatch. Only the first 8 MSBs, most significant bits, will be transferred, will be copied to the base register, and the last remaining 8 bits, which are LSBs, of course least significant bits, will be dumped, will be removed, will not be transferred. So it is an invalid command. Same goes for move ds comma ss. So note here that ss, our source, is the stack segment register, which is a segment register, and ds is also a segment register, display segment register. So here is an important point that direct transfer between both any segment register is not allowed. So first you have to copy the value from stack segment register into accumulator register. Like the command will be move ax comma ss, and then you have to move right, like move ax comma ds, sorry, ds. So you cannot directly transfer it, so it is invalid move instruction. So move instruction tasks, here's a task for you, like move al comma 12h. What will be the output? Like 12 hexadecimal number will be stored into accumulator lower bit. And second one is move ax comma 123ah. So 123 here, 123a, 123a, there are 4 digits, so every digit occupy 4-bit size. So here total will get 16 bits, and we are going to move 16 bits into AX, which is a valid instruction. So move CL comma OCDH. Here H is not a character, H is not a data. It is just representing like hexadecimal value. So OCD, there are total 12 bits. So we are going to move 12 bits into CL, counter lower register. Here in CL, OCD will be moved. Now talking about memory addressing examples, move AL comma 1234H. Here 1234 16 bits, and we are going to move into AL. So it is like invalid because 16 bits cannot be moved into AL, which is 8-bit accumulator lower register. So for the address, physical address, we are going to use this example. So address will be 1234H because whenever a square bracket is around instruction, it is representing a memory address. Second one is move EAX comma square bracket BX. So note that if we are given with the value of BX, which is 0300H, and the value of DS is 0200H. So what we are going to do, like the data segment multiply by the 16 bits. Data segment, why are we multiplying it with 16 bits? Because we are using 4 bits, 4 digits here. So DS multiply 16 bits, 0200 multiply 16 would become 2000, and 2000 plus 0300 will become 2300H. So it will be the address. And move DI comma AL, DI value is 0400H. Same we'll do for it too. For DS, we are provided with value 0200, so multiply with, it with 16, and it will become 2000. 2000 plus 0400 will become 2400H. So this was all for my side, and hope so that you understood the video. And if you understood the video, or if you have any queries, you can ask in the comment section. Peace out. Allah Hafiz.